I've been in science for a long time. I've worked inside the cells, if you will, with the details, all that sort of thing. It's very, very complex. It's infinitely complex, biologically speaking. It's just infinitely complex, but that's a source of great confusion. When we just look at one thing at a time, we can find anything we want. I mean, I could give a lecture here why we should eat meat, basically, if I worked on just the details. So I want to share with you the idea that when you look at not only the totality of the evidence, but also see how it actually works in the body, inside the cells and stuff, it really becomes very convincing. It becomes very convincing that it really is all about consuming only plants, and in particular, avoiding animal protein particularly. So my story today is focused on animal protein, and if you don't mind, I'm going to have to go back a little bit personally, because I'm here in this space, as Wes just mentioned. That was me, and my two brothers did the same thing back in the late 1940s, and early 1950s in Loudoun County, just west of here. So I went all over that county with that combine, cutting grain. We had the first combine in those days. That was a big deal. And so it was primarily for the purpose of my dad, who only had a couple years education, formal education. That's elementary school. He wanted me to get an education, so we had to raise the money, and that's the way I raised the money to go to school, because he wanted to go to school. In any case, in due course, we sold the farm. I was raised on a farm and milked cows from the time I was 5 years old. So I'm very much up to here in farming, I can tell you, without a doubt. And so when I went away to school, I was thinking just like everyone else. The good old American diet is basically as good as it gets. So I was at Cornell University, right? We sold the farm. And by the way, I should tell you also, I think Gwen mentioned this, when I got my first professional position, was working with an FDA laboratory here in Herndon, a little town of about 500 to 1,000 people, just a couple of blocks from here. And when I went into that office for the first time, I saw somebody kind of caught my eye. And sure enough, we got married. That was 60 years ago. Here in the Baptist church, just 2 or 3 blocks from here. So it's like coming home for me in many ways. I just had to say that because that's where I got my start, coming from the farm and so forth. But in any case, when we left the farm, milking cows and that sort of thing, to the extent that I even heard of this, I'll say I did. But to the extent I thought about the diet or the nutrition thing, it was all about making sure we get enough protein. That was the key. And what that usually meant was getting animal protein. And so everybody bought into that idea. I eventually went away to school at Cornell. I finished my graduate work. Went to Virginia Tech not too long thereafter. I was responsible for coordinating a program in feeding malnourished children, malnourished or starving children. That had made a major impact on my early life because what I saw there was something different than what we were supposed to be telling. In other words, the general idea was, of all the malnourished children in the world, a pretty serious problem, the thing they most needed was more protein. That was the idea. So when I was in the Philippines, coordinating this State Department project was at Virginia Tech, we were supposed to be making sure the children got enough protein. So the kind of protein we're supposed to use is animal-based. So once again, from my personal background on through school, doing a graduate degree and actually promoting animal protein, I was in the Philippines then trying to sell the idea that these malnourished children would resolve their problems by eating more protein. So, but I saw something. I saw something in the Philippines that was troubling for myself, as well as for my colleagues. There were a few children in the Philippines who ate protein more like we do in the West, like 2 or 3 or 4% or something. And thanks to a couple of colleagues of mine in the Philippines, also with my knowing the research available at that time, it seemed like the children most likely to get liver cancer were consuming more protein. I mean, there I was presented with a dilemma. We're supposed to be pushing protein, but these children maybe getting liver cancer. So I came back to Virginia Tech and organized a research program that lasted for the next 35, 40 years. all supported by NIH. In the beginning, simply asked that question, because I didn't quite believe it. How can animal protein do what I'll show you in a moment? How can animal protein be associated with more cancer? So that was sort of my introduction in many ways, because I saw something opposite of what I thought I knew. So I had to work hard with lots of students and pretty big research program to try to figure out whether that's true. And eventually, over the years, I not only was convincing to me that it was true that animal protein causes experimental cancer, without a doubt. These are experimental animals, by the way. But I also learned a great deal how it works inside the cell. And it's that idea, learning how nutrition works in the body, in cells in particular, that now just tells me a lot about the plant-based diet. So let me show you just a couple of things here along that line. Oh, incidentally, in the Philippines, I also saw at that time, first I had the impression that a few children getting the most protein got cancer compared to the others on the one hand. On the other hand, this report came out here in India. It was an experimental animal study where they actually were testing the ability of level of protein on forming cancer in an experimental animal study. You can see this in 1968. And they concluded, you can see here, that the animals given 20% of total calories as protein, animal-based, they got cancer. 100% did. The animals given lower protein did not. That's what I saw. And I thought I was seeing the same thing with the children too at the same time. So clearly I had a responsibility at that point to essentially go back and challenge the system, I guess. The system for me, I got the grant money from NIH that continued for the next 3 or 4 decades, one way or another, and I became convinced that it was true. Let me show you one of the couple of things here that really became quite convincing. We published this extensively at the time, and by the way, in the early part of my career, I was mostly in pharmacology, directed toward the concept of using drugs to solve problems. Well, those are nutrition, so it turned out nutrition won over pharmacology. But let me show you this here. This is the part that I found really intriguing. This is the growth of cancer over the first 12 weeks as a function, this is experimental animals, as a function of level of protein consumption. So both groups of animals started out with the same sort of starting point for cancer. These were animals that have been exposed to a carcinogen. One group was fed 20% protein. That's kind of on the upper side of what might be normal. You can see the cancer growing very well the first 12 weeks. Animals fed 5%, not at all. That's huge. That's huge. And so that was consistent with what I saw with the children too. So at that point, I'm being warned by my colleagues, don't go there. That's crazy. They've got their animals mixed up and so forth and so on. That's another story. But I kept having to push away and trying to convince myself as well as my colleagues there's something to this. So in any case, big difference, 20%, 5%. And then we did something else. We actually switched the diet during that 12-week period. When we gave 20% protein to cancer growing, if we switched it to 5%, the same month, the cancer turned it off. So we could turn cancer on and off by just elevating protein or not. That's pretty convincing. That is pretty convincing. There's something there. And so, and I became convinced that, there's something there. We did that many times over the first 10, 12 years. And in the process, this idea here came up. And this is a real fundamental structural idea, ideologically. Namely, we tend to think cancer is a genetic disease. That's what's published by the National Cancer Institute. It's a genetic disease. You get cancer basically according to whether you have the genes to get cancer. What we're showing here is that's not really the full answer. We can start out with genes that might create cancer, let's say, but cancer occurs basically according to our diet. So when we're eating an animal-based diet, lots of things change, that's when the cancer grows. If you switch it back again, it suggests that was going reverse. These are studies here that were done in the 1970s. It was all together new at that time, and I was kind of getting in the back of the neck, showing this kind of stuff because I was essentially violating traditional thinking, which was a lesson in and of itself. Anyhow, plant protein didn't do it. Animal protein turned on the cancer, plant protein did it. That was so dramatic. That was so dramatic. We did it so many times over, different ways. It was clear. Animal protein turns on cancer, period. That's all it was. It's very, very dramatic, too, at that. And it happens quite fast. So then, being in pharmacology as was, as a professional at the time, the way that we generally think in pharmacology is, if you see something like this that looks crazy, then why not find the mechanism biologically? Why don't we find a mechanism responsible for that? Because if we can find a mechanism, then maybe we can get a chemical. Maybe we can get a drug. Take the drug and give it to people and so they don't get cancer, and they keep on eating the same diet. That's what the statin industry is about, I should tell you. Statins are focused on one mechanism to block heart disease, which we know otherwise from the display on that one. So we were looking for the mechanism. And this turned out, I can't go into the details here, but it was really quite fascinating after about, 12, 15 years, I think. I'm going to show you here now, please don't get, I don't want to lose you on this. When we studied cancer experimentally, we tended to work out the idea that cancer comes in 3 stages. First off, we have the gene to get cancer, which has been modified by some chemical, let's say. That's called a mutation, okay? That's the first stage. And then the cancer starts to be, the normal cell gets converted to a cancer cell. That's the first stage here, if you can see here, over here it's called initiation. After that, normal tradition has it that once you get these cancer cells, infant cancer cells, now they got the potential to cause cancer, then that's when the cancer starts dividing. These cells dividing. Eventually they grow into a tumor. And in the case of humans, suddenly, after maybe a few years, we discover we got a problem, so we have to go to the doctor. That's when they diagnose. That's when the cancer is becoming more serious. That's when the cells have decided to go elsewhere in the body, metastasize, we call it, and then it can be quite serious. So the second stage we call promotion. So my task was at the time to look at both stages. By the way, the third stage is progression. That's when things are getting pretty serious. So I wanted to find out what the mechanism for this was, because keep in mind, it's a hard story to sell. In those days, it was an impossible story to tell. I'm crazy. This is not, you don't go there, don't even talk about this, because the animal protein is so important. So what we found at the end of the day, after these years, and this is, for me, probably the most significant thing we did in our research over the years, we found that animal protein, when it's increased, it hits 8 mechanisms, enzyme catalyzed mechanisms. It hits 8 mechanisms that turns on cancer. Okay, we looked at a couple others, and a couple of others, the animal protein actually, when he elevated, actually decreases 2 mechanisms. So what do we have here? We've got 10 mechanisms, and each one of these is usually worth a doctoral thesis, quite frankly, so it took some time. And it was altogether new in those days, but it turned out of those 10 mechanisms, 8 are increased, 2 are decreased with the animal protein. So the animal protein is increasing mechanisms that cause cancer. And it's actually decreasing 2 mechanisms that are there for us to protect us from getting cancer. One of them is called immune cells, T cells, you may have heard of in modern day. And so we call it natural killer cells. But in any case, this whole idea that every time I look for a mechanism that traditionally might be amenable to developing a drug, we found a mechanism. So which one here is really, which one do we do? Which one do we pick out? Sort of maybe to invent a drug if somebody would want to do that. And of course, my interpretation of that, there is no such thing as the mechanism. So you hear today a lot of people talking about this works this way and here's the mechanism and so forth. I've been there, I've done a lot of that. I've gone past that because it's not a question of which chemical causes which mechanism. It's really not the answer, because that's a source of enormous confusion. Because I can find mechanism all day long for the next 20 years to sell any story I want to sell. I can sell you a story that they made probably by selecting out one mechanism at a time. I call that the parts. It's the whole that matters. So then the question is, how do you have this enormous complexity, enormous opportunity to look at the parts? Well, that's what I saw in the cell. When all these parts come in from, let's say, plant-based foods, when they come in the cell, there's a magical way. This is Mother Nature working. all these mechanisms, all these things, they come in and they kind of weave together and they create the whole instead of the parts. And Aristotle told us this more than 2,000 years ago. The whole is greater than the sum of its parts. And much of the confusion we have in this community, as well as in other communities too, and it leads to confusion. People are not completely convinced that it works because we tend to work on one thing at a time. That can kind of look impressive, you can find those kind of things. But it's not really the answer. The answer, look at it in its totality. When you see that, and you see nature just grab onto everything she has access to create this mix, that's so impressive. That is so impressive. That's what got me really into the whole food plant-based thing. Starting out with protein alone, and then seeing some other nutrients, just realizing this concept. I mean, I found it spectacular, to be honest about it. 10 out of 10 that we started. A lot of research on each one over 2 years, each one. Finally decided, how can we just sort of search for 10 possible mechanisms, and every single one changes, whether it's up or down, but every single one that causes creative cancer. You stop and think about that. What's going on inside of our cells? And it's not just 10, it's 100, it's 1,000, it's 1,000,000 maybe. I can think of different kind of mechanisms. But the concept is what really just convinced me. It's the idea that all these things come in, we eat the right food, they all kind of work together. Mother Nature knows what she's doing. That's the key. So if we just eat the right food, to provide that, that's plants. That's plants. So how do we get caught up in this idea of society just relying on protein? That's the rest of my story. Western medicine basically is that idea that, hey, protein is important. Yeah, we need protein, there's no question about that. But a lot of people assume that the protein only comes from animals. No, it doesn't. It comes from plants too. Because then we had a system that sort of arose over time, that animal food, animal protein became highly regarded. It was called high quality. Plant protein was called low quality. So historically, over time, we became subconsciously believing that the only protein really mattered was animal-based. It's not true. It's not true, because if you go back and look at the real basis for that sort of misunderstanding, it turns out the high quality animal protein, a higher percentage of the protein being consumed is retained by the body. That was the original story. If more protein is retained in the body, and protein is important, let's say, what they saw was the increased growth rate. And that was the key to come up with this idea of high quality protein, animal protein, and everybody kind of bought into it subconsciously. The average person didn't think about this. All they heard about was the protein. If you want real protein, it has to come from animal source first. And I'm saying that we now know that, I'll show you in a moment, when protein is being consumed, and the so-called high-quality protein, a higher percentage retained for body growth. It turns out the higher the percent of protein retained, this has been within the last 20, 30 years, the higher the amount of protein retained turns on a hormone that creates cancer. It elevates blood cholesterol. You get heart disease. The cholesterol you consume does not cause heart disease. Saturated fat does not cause heart disease. There's a lot of confusion in the field just for that reason. Polyunsaturated fats from plants and stuff is supposed to prevent it. But the point is when we eat the right kind of food, and you look at it this way, you look at the intricacies of the reactions, you see, holy schmoly, this is something almost beyond our comprehension. It's beyond our common thought. Oh, let's put it in this nutrient, that one, or is this something else? No, that's really, we have to go back and really understand this concept, which I call holism. Incidentally, we did research in the early days that showed that the protein that causes this problem is casein, cow's milk, the main protein of cow's milk. That's what we all did research, it was available at the time. And so we got our hands on some soy protein and wheat protein, and it doesn't do it. Plant proteins don't do that. Animal protein does the mischief. It increases your blood cholesterol. It basically increases cancer, all those kind of mechanisms. And so, in any case, that's why I wanted to say I came from the farm. I'm milking cows up in Loudoun County. And, coming to believe in what everybody believed. And so finally, after 3 or 4 years, I said, okay, enough's enough. This information is real. It is absolutely real. And it means more, and it's far beyond just a question of protein. When we consume more animal food to get that protein, we consume less plant food. What does that do? Less plants are good. They got the fiber, the 1,000 different kinds of fibers. They got antioxidants up to Brazil, plants have all the good stuff. And so when you decrease the animal food, increase the plant food, you got a million things going on at the same time. That's nature. That's nature, and that's what we have failed to see. And so what my view is that what we stumbled across here was what Mother Nature is all about. And it's really fascinating, because once you get to that idea of this is the way it works with the cells throughout our bodies, and it happens within seconds, nanoseconds, actually. It's so fast. When you see that kind of thing, then the only conclusion you can really draw, then it must not only have to do with heart cancer, it has to do with heart disease, it has to do with diabetes, it has to do with chronic kidney disease, so forth and so on. And so over the last 10, 20 years or so, some of these studies are now coming out, showing that when you eat this plant-based food, you're coming home free. Because whatever condition you may be concerned about or been diagnosed with, it turns out that under those circumstances, you eat this kind of thing, you don't need to think about which nutrient in that food is causing what. You don't need to think about the so-called key mechanism that might be amenable to some drug treatment. That's what the drug industry does. The drug industry has relied on the fact that when you see this complexity, they want to find one mechanism, right? And then they can create a chemical to make a drug. That's where the drug industry goes to. And so I end up in this sort of untenable position, according to some of my colleagues, having been both in pharmacology, drug, if you will, as nutrition. For me, nutrition really won out. There is no question about it. There's no comparison between sort of going the drug route and trying to figure out how to solve a problem. It really comes down to the question of nutrition. So now let me show you, just to add some weight to this, what I just said. I just did this recently. I went into the literature to find other researchers the last 50 years, if you will, 70 years actually. A lot of the people I knew during this time, I'm unfortunately old enough to know them. I want to just show you some of the research others had published. Not being aware of what I just said, but they were showing the relationship between the consumption of animal protein-based foods versus some diseases. Look here what these charts show. Here's a study here. This was done in 1959, where they showed that the higher, in this case he did say percent protein, the higher the protein, that's on the x-axis at the bottom, different countries, the higher the protein, animal protein, the higher the heart disease. See that straight? I drew that, I used an algorithm to calculate, just from visual inspection, to calculate whether or not it was a straight line. So what it came out to be in science is a regression line that's linear, coming straight down, almost coming down to the zero origin. What that says is that if we have no animal protein, essentially in theory, we have no heart disease. That's pretty impressive. How can we, that was published in 1959, got forgotten. Here's one for kidney cancer, another research group. They kind of been lying there, not developed in the way that I'm telling it here, but kidney cancer, same thing. Increasing protein intake increases kidney cancer. Wow. Heart disease, kidney cancer, there's two of them. Here's one here, increase in non-fat milk. Prostate cancer. This was done in the 1980s by somebody I know. In the case of this here, so they said non-fat milk. They're kind of afraid to say animal protein. I'm not sure they even thought about it. But in reality, non-fat milk is a protein drink. It's an animal protein drink. So the conclusion from this is not that non-fat milk is bad because it got this, that, or something else. The conclusion is we are consuming an animal protein drink. That's the big thing. Here's another one here on breast cancer for different countries. He's a friend of mine from Canada, quite 30, 40 years ago. But in any case, he was able to show, comparing countries, that if you compare countries, the amount of, in this case, saturated fat was consumed, the higher the breast cancer. This particular chart here was probably the most cited study in the next 20, 30 years, leading people to conclude, if I just don't eat the saturated fat, I might not get breast cancer. I say it's wrong. We can say a little bit of effect maybe, but the big story here is the fact that saturated fat is primarily found in animal food. So there's a representation of animal protein. It's a representation of our desire to consume animal protein. So we end up eating animal food to get the protein, we get more breast cancer. Look at that line there. Linear regression right down through the, as I say, the XY origin, suggesting that no saturated fat intake, really mean animal protein, no breast cancer, okay? Here's another one. We flipped the charts here, the XY origin. You got the cause, cholesterol intake on the Y-axis and then the heart disease on the X-axis. But nonetheless, same thing again. This is what led to the popular notion a lot of people bought into. Cut your cholesterol intake, get less heart disease. Yeah, that's not true. It's true only indirectly, because cholesterol only comes from animal foods, right? But it does not suggest that cholesterol causes heart disease. Yeah, it accumulates with blood vessels, but that's not the real cause. This research was explored in some depth over 100 years ago, in 1907 first, and then concluded in 1920 that it's not the cholesterol that causes heart disease, it's animal protein. But it got ignored. Anybody who said it was animal protein are out of here. That was the state of affairs, because we can't challenge this idea that animal protein is not a very good idea. But there you can see it. It's another straight line relationship. Here's one, colon cancer and meat intake. Well, that's pretty clear. Meat is mostly a good source of protein, animal protein. You can see that relationship. See all these lines coming through there? I just did the linear regressions of all these, and they all showed the same thing. You know, to get right down to where zero intake of whatever the nutrient is that we have been talking about, no disease. In this case, a different disease. Here's uterine cancer, total fat intake, which tends to represent animal protein intake. So here, increase more animal food intake, which internationally means more total fat intake. And you know, people tend to believe that if I can just cut my fat intake, I won't get it. That's a little bit short-sighted. Yes, it works in a sense when you change your total diet. But the saturated fat itself is a worse fat is the fat from plants, polyunsaturates, because that's a pro-inflammatory. When you take it out and put it in a bottle, the fat is in the food. The fat's in the food. If you're using whole food, it doesn't make that much difference. That's another whole story, and I don't have a chance to get into that. But when we take one nutrient out of food, we put it in a supplement, do this, that, or something else with it. When we do that, we get results sometimes exactly the opposite of what we thought. So I want to come back to the concept. Just eat the whole food. Eat the whole food. The odds of actually creating health for yourself and actually reversing disease in a number of cases. That's where the bottom line is. So what was it? I showed you 4, 3, there's 7 studies here. These are just studies that I happened to fish out of the scientific literature just maybe 3 or 4 years ago. I wanted to go back and see the extent to which if I could, do a regression line on these things, and they all show the same thing. They come under different names. Oh, saturated fat is bad. Total fat is bad. Skim milk is bad. That's not the answer. Because when you take it out and you make changes one thing at a time, yeah, you can see a little effect in the short term, maybe. It impresses you if you already believe it impresses you. But in reality, if you look at a lifetime, no, it's not really the way to do it. The only way that we can really achieve getting this kind of diet to work is basically getting on and eating the whole food. So here I put this thing here. It says animal protein, basically surrogates, I call it. Cholesterol, meat, total fat. All these things here that we tended to assume are important causes, and we change the diet with one thing at a time, that is not the way to look at it. That's not the way to look at it. We have to look at the totality of things. Now, I want to show you with this. So animal protein has become the kingpin throughout history. Protein itself was discovered in 1839. It was found in meat being fed to dogs. And so these dogs would grow when they got the meat. It's pretty straightforward. So the scientists at that time in Holland, the scientists, said, let's see if we can find something in there that might account for this. Mind you, that's 175 years ago. Science, technical science hadn't been quite very advanced, obviously. So he fished out a chemical in that meat. Then, that's it. It turns out it was protein. So protein was discovered as a non-entity. It was just a chemical because they found out we could fractionate that, put the protein back, and the animal would survive. So we need to have a name for it. So the word came on the word protein. Protein is not an accident when they called it that. Mind you, in that day and time, you could say anything once he came up with a name. What he came up with was a name coming from the Greek word proteos, P-O-T-E-I-O-S, which means first. Later, protein was called the stuff of life itself. Some of them even said a couple of decades later, is the stuff of civilization. That's a fascinating story, by the way. But that's what the history shows. Protein was discovered. It got the name protein from, according to baptism, from the Greek word, first, or prime importance. That got so into our psyche from the 1850s onwards that we could think nothing different. And so the whole society thinks, man, we have that protein. Brings it back to that story again. Well, what about plants? Oh, plants got protein too, but then it was decided the animal protein is better because you retain more. Retain more from what? Get heart disease? Get cancer? So, the history lesson here is really kind of fascinating. So now, with all that said, when I look at animal protein, look at all the mechanisms and, that kind of concept of working together, and then I also look at it in the context of policy. I spent 30 years very intensively involved in government policy here in Washington and elsewhere. I was on some of the senior committees. In fact, at one point, I did hold the position of being the representative to Congress for the entire Biomedical Research Agency. So I can tell you, having been there in the government structure and being involved on committees to decide who gets grants, who doesn't, that kind of thing, it's kind of fun in a way, but I also saw things at the governmental level I didn't think I'd find. Really troubling. So I can tell you story after story of details. I saw, and one of the things that drove me to really get involved in that at the time, one time I was getting noted, New York Times and People magazine and everything else, but I was coming out and saying different from what they thought I would say. And certainly I was saying something different than what the authorities say. So I really became quite familiar with what happens at the senior level. What happens at the level of dietary guidelines? What happens at the level of formation of the recommended amounts of nutrients and that sort of thing? Here's what comes out of it. I'll see if I can summarize this. This is really critical. This what I'm showing here is a range of possible protein intakes with some numbers on this spectrum. Let me tell you what some of the numbers are. The 5 to 6, this ranges from a low level of protein intake, okay, to up to a high level. So 5 to 6% of total calories as protein. That's all we need. That was determined in 1943, many years ago. That was determined, that's all the protein we need. Right around 5-6% of total calories. At that time, the researchers, and every time since, they've supported the idea, okay, yeah, 5 to 6% is what we need, but let's increase that by 2 standard deviations. That was the rule of thumb, statistical adjustment, just to make sure that what was seen at that time would cover everybody. So we got then familiar with the idea of recommended dietary allowance. That's done by the Institute of Medicine and National Academy of Science. I've been on those committees myself. I know that background quite a bit. So we end up with a recommended dietary allowance, or recommended daily allowance. How many have heard of RDA? Okay, so the RDA, that's what it means, recommended daily allowance. We tend to get to know those numbers more or less. You might see it on the labels of food and this and that. But the minimum amount we need is 5 to 6% on average for that experiment was done at the time. So they increase it just to make sure everybody got enough protein. So the RDA is plenty enough protein for everybody. The 9-10% is enough. Unfortunately, some people wanted to make that the minimum. That's not true. So everybody got the idea, I want more than that. This protein is really important. So what did we do as a society? What we did, we assumed a range of protein intake in this country between about 11% and 23, 24%. These are good figures, okay? So as a society, we got enamored with this protein concept. We got to consume more and more. And so what kind of protein did we consume? 75 to 80% of the protein we were consuming as a society comes from animal sources. So we became a carnivorous society in many ways, largely because we were fascinated with the idea that we had that protein intake. It really came down to the protein intake. And mind you, as I said before, when you choose to eat the food to get the animal protein, for example, you decrease the consumption of plant protein. So there's a combined effect here when you see this. So the intake range is like I say, right around there, is from about 11% to 20 to 23%, something like that. That's the range we're living in, okay? Now I'm going to show you, I'm going to superimpose on this chart here. Can you recollect? Look at my chart up in the upper left-hand corner. You can't see those little charts, but what I'm showing you there, those are the charts I just showed you for population. The level of disease we get as a function of nutrient intake, protein intake, if you will, you can see there. They're all there right there. That on average is what you hear this dotted line. In other words, 90% of us are consuming diets in this country that are actually associated with increased risk of, small at the beginning but high. So in other words, we got overwhelming data, I think, to show that when we increase animal protein intake, you're going to get one of these diseases. That's why 85% of the people in this country now have been diagnosed with diabetes, heart disease, and cancer. That's why. Because we're all consuming that kind of diet for the whole time. And hoping to take care of their problems when given a drug. That's the narrative. That's the narrative we all tend to live with. So anyhow, there's that line there that's superimposed on it. By the way, passing, I should say, the 9 to 10% protein we need can be provided by any plant-based diet. Any plant-based diet. As long as you consume a whole food. So you never have to consume an animal food to get that protein. I'm talking about dairy and eggs and meat, the whole 9 yards of it. We get all from plants itself. So that's where the whole food plant-based, I'm the one that actually came up with plant-based wording, if you will. I was on a government committee at the time in the late 1970s when some of my colleagues in cancer research were hearing about the possible nutritional effect on cancer, and they wanted me to give them a little update on what I thought about nutrition. I didn't want to use the word vegetarian because it doesn't set that well, quite frankly, scientific committee, so I came up with this kind of crazy term, plant-based. That was in the late 1970s. It was 2 years later I added the word whole. I won't get into that here. But it's been quite a long time, since the late 1970s until now, this word plant-based is coming into play. It really seems to be spreading. It's and in one sense, it's kind of gratifying, I guess you could say. But on the other hand, we also have a problem because the plant-based idea is now beginning to use to justify the production of foods. Plant-based meats, you've heard it, and all that sort of thing. And that's not quite what we're talking about here. What I'm referring to, if you want to really be healthy, just eat plants, whole food, and you get at least 90 to 95% of the benefit that you can theoretically expect. So anyhow, these recommendations are set every 5 years by the Institute of Medicine, National Academy of Science, okay? The Institute of Medicine, the National Academy of Science is a big name organization. They have set the minimum intakes of nutrient intake and adjust them every 5 years since 1943. I know that group well. So the Institute of Medicine is like the Supreme Court of deciding on how much nutrients we consume. And that's what everybody comes to. They look for, they've got a mindset to look on the numbers. They look on the labels and things, what have, that kind of thing. So it's a big deal, those recommendations. Well, in 2002, which was 2 years delayed from 2000, because really a 2000 report. In 2002, they came up with a new idea not just talk about the minimum, how much nutrients we need, but in recommended levels, which they've been doing every 5 years since the 1940s. They came up with a new idea. And the new idea, they said, let's set the maximum safe limit for all these different nutrients. Maximum safe limit. So, just let the public know. Just let the public know. What is the maximum safe limit? For protein, is at 35% of calories. Now, to draw your attention back again to those lines there. 35% of total calories in the form of protein means you have to eat a total meat diet, 100% meat. That's what it says. There's no other way to get there. So you say, why in the world is this a very august body of people, scientists in the world, sort of coming up with this recommendation? We can go up to 35%. Okay, here's the way it works. In the National Academy of Science, they set the numbers. Those numbers then in turn are passed off to the USDA committee that does the dietary guidelines. So the dietary guidelines translate it to the public. And so when they do that, that's what happened in this case. The 35% was passed off to the folks at the USDA, the dietary guidelines, and they adopted it. It became part of the narrative. It became almost like a regulation now for the dietitians in the country. It becomes almost a regulation for the entire public to believe we can have 35%. The dietitians didn't even know this. I was a keynote for one of the state's conventions right after that, and I asked them. I said, just show of hands, how many of you know what the upper safe limit for protein is? Not many hands went up. Once I said 35, they all went up. So the dietitians came to know, if you will, that 35% protein is a good number. And therefore, you can consume 100% animal food. This is really quite insidious. This is actually what happened. I know the people involved, and I'm going to mention something here. I call it the mob power. This is the regulators. These are unfortunately, the academics in my community and others who come up with this 35%. They knew what they were doing. The chairman, the director of the Institute of Medicine at that time, that oversaw this. It turns out when I saw this number, I couldn't believe this number. I called a couple of friends on one of the committees. I said, why'd you do that for? They said, we didn't do that. So I looked on more. This is like a 1,400-page report, something like over 1,000 report. I said, well, there it is. No, we didn't decide to do that. But yet, in the New York Times and elsewhere, this news report came out here. You can't see it, I guess, but 2002. First line of the report of this announcement to the public, because it's a big new deal. Wow, we can consume protein up to whatever level and these other things. You see where the error is there? It made the first line of a very august, very prominent news release that got in the New York Times, got in Time magazine, got every place in the world. CNN, you name it. So, without probably none of you remember that number. I certainly was aware of it. What they were saying is, don't worry, folks, don't worry. We can consume up to protein 35%. What that was done, it was done by someone who was a director at the time of this exchange, making this claim. He oversaw this. It turns out that same individual went over to the USDA Dietary Guidelines Committee, and he was the chair at that time. He held two positions. First time in our history, one person held both positions. So over here, this committee here, they set the 35% limit, right? And then over here, sitting over here, the Dietary Guidelines Chairman, and there they adopted it. Now the public all here. Don't worry about this. It's a way to knock down the plant-based diet idea. I know this person very well. First name basis really well. He was the chairman of our department. He didn't care too much for me, to say the least. And so that's another whole story. But I just want to simply say that individual with some buddies, actually created this here kind of sort of sub rosa kind of argument that's crept into the society. Most people would never know it. You would never know it. And so for any of us to come out and say, 20% protein is too high. No, it's not, because we have regulation over it. I mean, you see what happens? This is the power of the industry controlling the politicians. That's really what it comes down to. So the larger percentage of the population, whether they're into plant-based diet idea or not, they feel justified to say, You know, we got numbers here to show us, whatever. Well, I'm just now engaged in a project that will become fairly public, and I'm going to name names. I'm going to tell exactly who these people are, and I'm going to tell exactly why they did what they did. Because that's the key person, the chair, as I say, knows really well. He's the one when he was at Cornell. I was teaching a course in vegetarian nutrition, kind of new. I wasn't all that great for the name, but anyhow, I was teaching this course in the 1990s. He came along when he got back to the department. He pulled my course out of the catalog without my knowing it. I went all the way to the president of the university to talk about this. How come? I wanted to speak to the faculty senate. And it turns out the president actually was an MD. He couldn't even do anything about it. I just wanted to have it airing for the entire faculty. Because between 3,000 and 5,000 students had signed a petition to have it restored. He couldn't do anything about it. He was powerless. Real power at the university was actually the board of directors, which includes 3 individuals at that time who were beholders of the dairy industry. And so you can get it. They can fire the president. So in the system, in academia, for example, we have this problem. And the only way I get away with saying what I do is because I've had academic freedom since I was 50 years ago. When I was, surprisingly, I was given that opportunity when I was in my 30s. Academic freedom is so crucial in terms of creating public information in this country. So I tend to speak out, but obviously I get in a lot of trouble for it. But what sustained my opportunity was in fact academic freedom. So they can say whatever they want to say. I'm going to go back and just talk about the science. Because in that way, eventually, maybe we'll get to know. So that's a tiny little bit of the story. It's much larger. It's much larger. And the institutions involved in playing this game, groupthink, let's call it groupthink. Let's call it paradigm. Let's call it, we as a group, we're in the professions, let's say. We're in the professions. And we all come to sort of believe the same thing because there's been somewhere along the line there was a sort of some statement made or regulation up here. We come to kind of believe it. We don't challenge. We don't know what we don't know. And we don't care to ask what we don't know. So that's a really key issue. We come, it's just really into the system, become part of the system, because that's our job. If you stray too much from that narrative, you get trouble. And unfortunately, academic freedom in this country, thanks to President Nixon and John Paul Stevens, who became a Supreme Court justice, they spoke out about this and said, university need to be kept under control. And so for the next 30 years, they worked hard to keep people under control and then reduced academic freedom. I'm one of the few people left in the country that has academic freedom that way. So I'm not going to waste my breath. I intend to actually tell what, in fact, we learned. Now, one more comment here I will make. Before I said, animal protein is considered high quality, and this was a publication in 1924, professor at the University of Illinois, actually. This is when I was in graduate school, so I knew about this. That's not when I was in graduate school. I was, some 3 years later, but I knew about this method because that was part of my thesis, believing in this high biological value. What it really means is that more protein is retained, you get more body weight, more profit for livestock-based agriculture. I know that. I'm over here that on the farm when you're sort of giving supplements to the cows and this and that, more milk. You're giving sort of high-quality protein to begin, especially pigs and chickens. That's part of the narrative. No one ever questions it. But what it means is, if this kind of protein, only animal-based, more retained, it means more retained to create increases in cholesterol, more retained to increase growth hormone, gives rise to cancer, more retained to cause some other mischief. And so when you look at it in this context, this sort of more holistic context, you say, wow, that's incredible. I'll just list some of the things here. No one in science today is talking about this, I will tell you. This is published. This is not hearsay, it's not just my interpretation. These are facts that the system does not want to talk about. More protein, more animal protein, the more that's retained, As I say, it increases blood growth hormone, it increases blood estrogen. Neil Bernard talked about the estrogen breast cancer thing. It creates more free radicals, which in turn associate with more cancer over time. It increases mutations, et cetera, et cetera. And it decreases natural killer cells, which are T cells. Today in the pandemic, for example, you might hear lots and lots of news out right now. The pharmaceutical company is busy trying to tell us, hey, they made a big discovery. They just found out that there's such a thing called T cells. Have you ever heard T cells? Okay, that's a discussion, front page discussion. They're telling us, T cells, that's it. In addition to the antibodies that are forming, T cells, also, they want to find a drug to increase T cell activity in our bodies. 35 years ago, we knew about the T cells. We did some experiments, and it turns out when you feed more protein, T cells go down. So, here's the point. Do we need a drug to increase T cells? All we need to do is change our diet. Decrease protein, that'll increase the T cells. I can tell you lots of stories about this conflict, this interface between the interests of the pharmaceutical industry versus the nutrition industry. What that does increases serum cholesterol, I said that before, blood sugar increases. So in other words, higher protein quality, or higher quality protein, and it does all those things. Who wants to have more cancer? More heart disease, more diabetes, chronic kidney disease. My son, who co-authored the book with me now, he's on the faculty at the University of Rochester, just recently published a paper showing for a gentleman who was 69 years old, chronic kidney disease is one of the big health cost factors. He showed, and it says that it got published, fortunately. When he took this gentleman over 4.5 months, he was on 12 drugs at the time. In that period of time, he got rid of 10 of them. He's healthy. He was about to go to dialysis. He got his health restored, and then the journal was asked him to actually make a comment as a patient. So he made a comment. He said he felt like a 20-year-old. You've heard some of the stories I think over here. These changes occur across the board. And I can tell you one thing, this is just for me common sense, but also based on some real data. If we see these spectacular things work in one part of the body, involving all kinds of things, do you think that Mother Nature would do something the opposite in another part of the body? Not during your life. This is a fact of nature. This is Mother Nature shining her light on our forgotten knowledge. And when you come to realize this concept, everything working, don't eat animal food. We don't need, because I always not liking what I say. I've heard that before. So anyhow, we just shouldn't eat animal food because there's no scientific basis for it, period. And I would hope that we would stop talking so much about individual nutrients, this, that, and other stuff. That's kind of helpful. Maybe you can sell people on the idea. But the real idea is the totality of everything working together. So, as I say, this information has been around now 20 years, 30 years. The people in authority don't want to hear this, so they never mention it. They still want to ride along with the idea, high quality protein is animal food, therefore we need high quality protein. That's it. We have problems. So we end up with something like this. That's different than what it was for me when we were on the farm. I was working cows up here in Loudoun County. Now it's just, the whole thing is just turned around. Now we're just using animals, something considerable. And I would argue, if you look at the literature, the extent to which this belief system exists is because of our belief in the importance of protein more than anything, especially high quality protein. If you go behind the scenes, I mean, a lot of them probably are not aware of this. They're not making a decision because they know this. This is not the point. It's part of our background discussion that sets standards and so forth and so on. So we got a problem. And if you look on the web right now, it's really interesting. I get discouraged at times because I think we know enough now to cause change at a senior level. And you would think this word is getting out around the world. You know, organizations like this we can get individuals to sort of, you folks to come along and sort of listen to this kind of stuff. But if you look on the internet, most of the stories that are out there right now is not about let's figure out some way to bring this food thing under control. It's not about that. Have a look for yourself. Most of the articles about how we're going to meet the demand for animal protein going into the future. China's increasing their animal food consumption. A lot of the countries are just increasing the rates of food consumption, setting their standards high, all because they've drunk the Kool-Aid. They've drunk the Kool-Aid. It's part of the narrative worldwide. I know this because in all my years involved in China, I'm really senior people. I even asked them, why did they set the recommendations so high? And their answer to me was, these are the people who actually were involved. They said, because you in the United States, you've had economic affluence, you've had your great growth, et cetera, and you got there because, this is the 1980s, by the way, you got there because you were eating animal food. That thought is so pervasive in our minds worldwide. It's so pervasive that they wanted to set the standards, and so everybody still believes in developing countries. China's hardly a developing country, I must confess, but it was. In a lot of countries around the world, people, first thing they want to do is get animal protein to eat as soon as they get enough money to buy it. So, not a problem. So we all get sick, and I want to say something here that's pretty provocative, I guess. The USDA has dietary guidelines, right? They are teaching us to eat the wrong food. That's okay, never mind. And they're livestock based. We can eat that food, we get sick. But that increases the number of people who need drugs. So we got another department, Health and Human Services, they say, don't worry about that, we got the drugs. So the whole paradigm is one part of the government is telling us, it's okay, they use our subsidy money, they use all the kinds of money to teach us to eat the wrong food. I'm not saying individuals think this way, that's not what I'm saying. I'm talking about a collective consciousness. We're consuming the food we're told to eat, we get sick, and therefore we get sick. We can solve the problem by there's some drugs. That's what it comes down to. So it's really a concept that's pervaded our entire community without our knowing it, for the most part. I mean, some folks do. So we use drugs. Here it is right here. We're the only country that advertises drugs on TV, except for New Zealand, but I was on a podcast in New Zealand, and they tell me they're changing it. So we're the only country right now that is using pharmaceutical, drugs, advertising. We're number one in the country, in the world. It's going to per capita use of pharmaceuticals. Do you know that our use of pharmaceuticals is the number 3 cause of death? Right behind heart disease and cancer? When have you heard that? The CDC has a list of 10 chief causes of death. They will not list this. They've known about it for 30 years. They will not point out that our use of prescription drugs is the 3rd leading cause of death. We use drugs, we eat the wrong food. So we pay a consequence. Our life expectancy is the lowest right now. It's been going down. Our life expectancy is the lowest of the Western countries. We're at the bottom. It's been going down. Is that testimony to the use of drugs? I don't think so. I think this issue is really, really important. We just need to get to the bottom of the basics. And I would argue that it's really about the science. I can't let you go without sort of putting on one thing here. This plant-based nutrition certificate that we've had now for about 15 years at Cornell. A lot of you have already taken the course. My daughter, who had her doctorate in education, curriculum development, international development, so she's now running the thing. It's quite exciting. I get to your attention. And this is the latest book I just published in 2020 called The Future of Nutrition. I'm basically trying to argue there that in order to go to the future, one thing to have sessions like this, which is all good, but if we want to get to the future, get the world changed, we've got to look at a different dimension. We've got to realize that the system is educating the public in the wrong way. This system itself, the economic, political system of which we're all a part, and participating in it. We've got to understand that metric, that dynamic, to really get a feel for what's really happening. Leave you with that. Thank you very much.